You don't have to do everything on mean. You can do all your statistics on median itself, and it is called robust statistics. When you say robust, it's robust to outliers. The statistics, the part of the statistics is robust to the outliers. But what we are going to learn is non-robust statistics, because that is what is used by the industry today. And robust statistics in general, uh, non-robust statistics will in general outperform the robust statistics. Okay, whatever statistics we are going to learn is not robust. Just remember that. Is that clear? So all the statistics developed on average is not robust. All the statistics that is developed based on median is always robust. Any questions on this? This is something extra that out of the syllabus, but I just wanted to mention that tomorrow when we start the inferential statistics, these things will come in. Any questions on this?
No, I'm good, Sandeep.
No, Sandeep. Fine.
Oh, good. Okay. Okay, then we started with mode as well. Then we realized that there is a single mode and bimodal data, and sometimes there will be also no mode also. So most of the times, average and median is always there. But if someone asks you, is there a mode always? The answer is that mode might not exist in some cases, and it might exist in some other cases. So it depends on the data. Then we talked about the dispersion. So first is the range, which is nothing but the max minus min, and the interquartile range, which we already discussed, and it is nothing but the Q3 minus Q1. And finally we started with standard deviation, which is having a formula of x minus x bar, sigma x minus x bar whole square by degrees of freedom. But here, the degrees of freedom depends on whether it is a sample or whether it is a population. All these things are dependent. We'll see how. But I just explained how the degrees of freedom works. So in any equation, if the value is known, if the outcome is known, for example, x plus y equal to 10, the outcome is known because outcome of x plus y is always 10. Because of knowing outcome, it means that we can only freely select only n minus 1 of the variables, because there is only one condition. But if there are more than one conditions, so the degrees of freedom will become n minus c. These things I explained already, but if you are having any confusion on these degrees of freedom, let me know right now, because we are going to use it now. Any questions on degrees of freedom?
No.
No, Sandeep.
No, I'm good, Sandeep.
Okay, very good. Yeah. So it's more like how many variables you can change, nothing else. The technique we can use is simply n minus c, which is also kind of very easier formula. Now, how would this get applied with standard deviation? Now, these things have different meanings for population standard deviation and sample standard deviation. So I'm writing sample standard deviation, and sample standard deviation has a notation of S. If you say S, it is a sample standard deviation. Now, I gave you already the generic formula above. So this is the generic formula that can be applied either for standard sample or the population. But depending on the population or sample, some of these values will change. So let me show you how. So I have given S equal to square root of sigma x minus x bar whole square by degrees of freedom. Now, how much will be the degrees of freedom? Now here, Vidya yesterday asked me, how would we know the conditions? So I gave a number of variables minus number of constraints. How would I know the constraints? So it depends on the problem at hand. So in standard deviation, what is the condition that we are going to satisfy? So we are using x bar here, and we know that yesterday I have shown you by simulating, we know that sigma x minus x bar is equal to 0. And this applies for any x bar. When I say x bar, where, what is x bar? X bar is sample average. And remember this very keenly. There is a difference between sample average versus population average. I'll show it again by taking another sample and trying it out. But here x bar is nothing but sample average. So when x bar is sample average, x minus x bar, sigma x minus x bar is going to be 0. And this constraint is always satisfied. And in sample standard deviation, we are using x bar, and this x bar has to satisfy this equation. So this is my constraint. Now, how many degrees of freedom? You can easily say it is n minus c, which is nothing but there is only one constraint, right? So the degrees of freedom will become n minus 1. Is that clear what I was saying? So here the sample standard deviation will become like this: sigma x minus x bar whole square by n minus 1 will be my sample standard deviation. Any questions on this before I move
So
on to
here,
the population?
here the constraint you mean sigma x minus x bar equal to 0. That is the
Yes,
only constraint here. Okay.
that is the only constraint, because x bar has to satisfy that, right?
Yes.
When you are using x bar, it means that x bar is always already satisfying this constraint implicitly. And I'll
Yes.
show, I'll simulate it again. Yesterday I have shown already. I'll simulate it again so that you'll get that concept again. But that constraint is being satisfied by x bar. So my degrees of freedom will become n minus 1. So the denominator I am replacing with n minus 1. So this is your sample standard deviation. Is that clear, or anyone has any questions or concerns? The exact theoretical proof I am not doing. If you are interested, you can see something called Bessel's correction. It's called Bessel's correction. Actually, this should be an exact average. So what I mean is, how many in this? So when I say sigma x minus x bar, how many x's I am adding? N x's. What I mean is, I am doing sigma x1 minus x bar, x2 minus x bar, plus so on. Xn minus x bar is what I am doing. So how many variables I am adding? N variables I am adding. Okay. So what I am doing actually here is, I am adding n different terms, each n different variables, and then dividing by n. Actually, I should divide by n. This should be like this. What I am doing? Average of different deviations from the center. But since if you add all these together without squaring, it is becoming 0. I am squaring each of these terms. Since I am already squaring, I am taking a square root to offset that square. But if I do like this, what I call this standard deviation is, it is a biased standard deviation, biased sample standard deviation. Why? The reason is I have n variables, but one of them is not free to change. I have n variables, but one of them is not free to change. When one of them is not free to change, it means that one of them is not a variable at all. So I have only n minus 1 variables in the numerator. So to offset that, I am using n minus 1 in the denominator, but this concept will be pretty involved to understand. So I'm not going further than this. Are you clear till now? Why n minus 1? Actually it should be n, because we want to take an average. But it is n minus 1 because there are only n minus 1 variables in the numerator. Are you clear, Vijay?
Yes.
Subbu and Abid?
Yeah, it's Sandeep.
Yes, Sandeep.
Okay. Now, what if it is a population standard deviation? How to do the population standard deviation? Let's see. Population standard deviation. And this one is denoted by sigma. Okay, in Greek, these are all most of the mathematics will involve using Greek letters. This is sigma, and this is also sigma, but this is a small letter of sigma, and this is a capital in sigma, capital in Greek, capital sigma and small sigma. So it's more like small a and capital A. So both are sigmas, don't get confused. This sigma we use for summation, which means if we want to add few terms together, and this sigma we use for standard deviation, that too population standard deviation. Is it clear? So don't get confused if I say sigma here and sigma there. Both are different sigmas. One is capital and another is small. Okay. Now, anyway, should I keep it or okay, I'll keep it. Now, what happens to the population standard deviation? Population standard deviation is denoted by sigma, and this is nothing but square root of sigma x minus, actually it is x bar in sample. So we should use mu. Mu is the population average. I have already given this
Yeah,
here.
it's Sandeep.
Okay.
In differences between descriptive statistics and inferential statistics.
Yes. I have given, okay, I have given in another page. Let me show it. Okay.
Yeah, here's Sandeep.
Average on a sample, which is on descriptive statistics, it is x bar. On inferential statistics, it is called mu. Similarly, for standard deviation, it is called S in descriptive statistics. In inferential statistics, which is for population, it is called sigma. So that's how you should take these things. So here, instead of using x bar, I should use mu because I am talking about population. If I am talking about population standard deviation, I should use population mean or population average. So the formula remains almost the same except these things by degrees of freedom. And it turns out that sigma x minus mu is not equal to 0 in population. I'll show you this. I will show you the both of the above constraint and this one. I'll show you how. But it happens that sigma x minus mu is never 0. unless it is accidentally 0. So it's not 0 by a rule. So now how many constraints? Constraints is 0. Variables are n. Now degrees of freedom will be n minus 0, which is n. Okay. Now this one will become
The sigma of x minus mu not equal to 0 will not be considered as a constraint here, Sandeep.
it's not a constraint, right? Are you having a rule that it is a 0?
No, it may or may not be. Okay.
I don't know what it happens.
Yeah.
So the problem is it may be 0 accidentally for some data sets. It may not be 0 for some other data sets.
Okay.
So if it is it's not by rule that I can prove that I cannot prove that this is not equal to 0 also, at least.
Okay.
The problem is it's not by rule that it is not equal to 0 also. Are you clear?
Yeah, yes, Sandeep. Now I'm clear.
I cannot prove that it is not 0 also.
Yeah.
So now the degrees of freedom will become n. So my population standard deviation will become sigma x minus mu whole square by n. This is my population standard deviation. Are you clear so far? I'll show you how this is not 0 by simulation.
Yeah, I'm clear, Sandeep.
Others, are you clear? This is a very important formula because we will be using this over and over again till
Yes,
the
Sandeep.
last minute. Till the last minute in this course. Without this, there is nothing.
Sandeep, I understood the formula, but what is significance of the standard deviation represents?
So, what does average represent?
It is middle.
It is a middle element, right? So let's
Yes.
say I have some x1, or let me give you a real example. Okay, let's say the question is about again the same heights. We can take the height data set. Okay, let's say I took 16 heights or 15 heights. Sorry, 15 heights I took.
Okay.
Instead of 10,000, here I have 10,000. I don't want to take 10,000 for the example. Now, if I take these heights and take an average here, what is average representing? It's some middle value.
Approximately middle.
But is it representing the entire data set?
No.
Sometimes I have 187. Actually, my height is only 162. Sometimes I have 150, and here I have something more than 150 on average. So it's not representing the entire data set, right?
Yes.
My standard deviation, it will represent the entire data set. The meaning is from average, how much is the deviation? That's what I am saying, right? What is the deviation from my center? That's what I said for the dispersion. How much the data is deviated from the center? What is the
Okay.
center? It's central tendency. What is central tendency? One of mean median mode. In this case, it is talking about mean.
Okay.
I have the middle value. I also have something else, some other statistic which says how much I am deviating from the average. Both of them, average and average and standard deviation, both of them together entirely describe the data.
Okay. Got it.
Okay, but you'll not understand how it is describing the data right now. But in the future classes, you'll understand how it is really describing the entire data set, both of them. So it is more like always you have to give, let's say I gave you a data. If I ask you to describe the data, always you have to give average and standard deviation together. If you give both of them together, I can understand the data. If you don't give one of them, I cannot understand the data. It's more like that.
Okay, Sandeep, got it.
You got it?
Yeah.
Okay. Now this is about the standard deviation. Let me show you why this is, how these two are working. I mean, sigma x minus x bar and sigma x minus mu. X minus x bar I already gave some intuition yesterday, but I'll give you again. Okay. Let's say I take some sample. Let's say I take some randomly I'm taking. I don't know where I am taking. Okay, some 50 observations let me take. Okay, this is my sample. Let me show you 1 second. Okay, I'm taking a sample here. This is my population height. Whatever you see in the column A, assume that this is my population heights. Okay, for your reference I am writing here. And here I assume that this is a sample because I am taking only out of 10,000 population heights, I am taking only 50. So assume that this is sample heights. Is that clear which is population and which is sample? The data on the A column is all population. That is my assumption now. And that the data on the E column is entirely sample because I'm taking subset of this main population. Okay, this is the simulation I'm going to use over and over again. So remember that even though in general, do I have this population data? Will I ever get this population data? I'll never get.
No.
I'm just simulating so that you'll learn. Remember that you'll never get the population data in any case, except in this kind of simulation. So I'm using some simulated environment. Okay. What is population average called? Mu. Right? So I'm
Yes.
taking the mu, which is the average of all the population data. Start from here, go to the end. This is population average, which is mu. What is sample average? X bar, right? Sample average is called X bar.
X bar.
Again, the same formula. In average, there is no difference in sample average and population average, but it depends on the data. Okay, let me try to select all this data. Now, is population average and sample average same?
Can you
No.
move the cursor once in from the sample? Yeah. Yeah. No. They are not same.
They're not same, right? Population average is 164 and my sample average is around 165. So population average and sample average never becomes same. And the second thing is, let's say this is sample 1, or let's not do that. Okay, we'll do that later. Okay, let's only concentrate on the standard deviation part. Now let's try to see x minus x bar. What happens? Let me keep it here. X minus x bar. What it will become? X is here. X is the sample data value x1 minus x bar. I'm keeping it as a constant so that I can drag it. I can drag it for the entire data set. Okay. This is my x minus x bar. Now what I have to do is I have to do a double click here. It's not working. Okay, let me drag it like this. Okay. What I got is x minus x bar. Let's do sigma x minus x bar. Sigma of x minus x bar. How do we do this? Sum of entire column K. This K column. I have to do a sum. Sum of from here. How to select the entire column? Control shift down arrow. What I got? Some 10 power minus 13, which is very close to 0. I'm approximating this as 0. So for sample x minus x bar, where x bar is the sample average, is going to be 0. Okay. Now what happens when I take instead x minus mu, where x is my sample data, mu is my population average. Remember this, x is my sample data, mu is my population average. That's how I can do x minus mu. Is it 0 or not? Let's see. X is this one minus mu is this one. I'm keeping a dollar to make it constant, so that I will subtract always from this number only. Let me do it for all the 50 observations. So when I do any simulation, remember this, how I did the simulation, why I did the simulation and all. Because these simulations are very helpful for understanding the concept. Because sometimes not everything we can derive in class. These simulations will give you better insights. Now I am doing sigma x minus mu, which is nothing but summation of sum of this entire column. Again, to select this entire column, control shift and down arrow. In Mac it is command shift down arrow. Is it 0? It's not 0. Okay, so here this constraint is violated. Sigma x minus mu equal to 0 is violated. That's why I don't have any other constraint. So I am using n in the denominator. Are you clear so far?
Yes, Sandeep.
I showed you how x minus x bar, sigma x minus x bar is 0, and how sigma x minus mu is not 0.
Sandeep, can you go to Excel once?
Yes.
This sigma x minus x bar is coming minus 1.98. It should be 0, no?
It is minus 1.98 e minus
Okay,
13.
sorry.
It means that it is 10 power
Yeah,
minus 13.
Yeah, got it. Sorry.
So it's only like a very, very small value, which is very close to 0.
Yes.
Okay.
Yeah.
I have a question.
Yes.
So when you calculated the x minus mu,
Hmm.
why were the x values from the sample data, not the population data?
Yes. The reason is you will never know your population data, but you might know in some cases your population average.
Okay, so even in simulated version, we should just use the sample one.
Yes, in reality, I cannot use this. If I use the data from here, from population, it will become 0. That is for sure. I can guarantee you.
Okay.
But the reason is, in general, if I go to, let me go back to this one. What did I say about inferential statistics? It's about the outcome talks about the population, but we can only estimate a parameter. What does it mean by estimation? This mu, I can estimate it could be it could be this value. It may not be the right value, but it may be closer to the population value. So I could do an estimation and select one mu and then use it in this equation. But still, I'll never have this population data. So even in here, I should use only the sample data. Are you clear?
Yes.
Okay. But you are right. If I take the population data itself, this will become 0 for sure. But I'll never have the data. That is the problem. Okay. So that is about the standard deviations. I think let's take a break because it looks a logical ending here of one topic. Let's come back at 7:10. Okay, 7:10 my time.
Sure, Sandhu.
Okay.
Okay.
Is everyone back?
Yeah, I'm here.
Subbu and others, Abid.
Yeah, I'm back, Sandhu.
Okay. Now let's talk a similar concept. It's called covariance. It's very much related to the first of all, let me talk about variance. I think you know about variance by now. Variance, what is variance? It's nothing but square of the standard deviation. Standard deviation. So again, sample variance and population variance will exist. So sample variance is equal to, it's denoted by S square. It's just square of the standard deviation, sample standard deviation. Now it will become sigma x minus x bar whole square by n minus 1. Now what is population variance? Population variance. This is denoted by sigma square. We can write it as sigma x minus mu whole square by n. Is that clear till now? So do not worry where we will use variance. Actually, we'll use variance most of the times than standard deviation. And the reason is variance is going to have some better mathematical properties than standard deviation. If you understand calculus, you'll know that square root is not much better. I mean, square root is not very good in a way. Anyway, I'm not going to describe too much about it, but you'll get to know. We'll use variance more than standard. Is that clear? So variance is nothing but square of the standard deviation. Instead of taking the square root, we will not. We'll just remove that square root and use only the term within the square root. Okay. Now, one small thing on Excel, if you want to do variance or standard deviation, we can use the Excel formulas itself. Standard deviation. So for sample, the sample standard deviation and population standard deviation are different, right? In standard deviation. So the same way, you have two standard deviation functions, stdev.s and stdev.p. Since this is the data that I am taking for sample, I should take sample standard deviation. And I take all the data. You can see this is my sample standard deviation. For population, the formula will be slightly different. So I should use standard dev.p. This is my population standard deviation. Again, I select the entire data set. This is my population standard deviation. Is that clear? In fact, I can relate this to the formula. Anyone, any questions?
Why did you use the population observations instead of sample observations?
In this case,
Yeah.
I'm just showing you how to do the population standard deviation formula.
Okay.
Because this, I assume that this is the population data. I just tried it out, nothing else.
Okay, but in reality, we don't know that, so we would still use
Exactly. Exactly. In reality, we'll not know. Almost 99% of the times, you'll not know the population data. But there are cases where you can get the population data. I'll describe you those for now. For example, let's say you are manufacturing some goods. Okay, some boxes, let's say, and each box, let's say you're creating using some wooden boxes, and you want to use only so much of wood. The weight of the wood you should not cross, let's say, 50 grams. So each box, what happens, during the cutting process and all, each box will have slightly different weight. So you want to see what is the average, a population average. Since you are manufacturing the boxes, you'll know all the boxes weights still now, if you noted it down somewhere. So in that case, what happens, you interestingly got the population data itself. So there are few cases where if you are manufacturing the things yourself, you might choose to collect the entire data and then you can do calculations on your population data itself. But the problem is, let's say every day you're developing millions of boxes. Keeping all these millions of boxes data forever will cost you so much. So that's another reason why population data doesn't exist most of the times. But if you are capable enough to save all the data, that's fine. You can choose to have, if you are manufacturing, then in manufacturing industry generally this happens. You can have a population data.
So
Is that
if
clear?
so if by any chance we have the population data, then we should use the population data to calculate the standard deviation.
Yes, by any chance, but it's more like very rare. But there is a way to do. That's what I wanted to say. Even in the rare cases, there is a way to do the standard deviation in Excel. Is that clear?
Yeah, but it's not this formula then, but or is it?
It is this formula, standard deviation dot p. P is the population.
Okay, sounds good.
On sample, I have used a different formula, standard deviation dot s. Can you see here in the formula section?
Yeah.
So that is the difference. Okay. Any other questions on this?
Oh, I'm good, Sandeep.
Okay, cool. So that is about the standard deviation and variance. Now there is a small related concept around this variance and standard deviation, and this is called covariance. This is a slightly related concept, so I'll cover it here itself, so that all the related terminology and concepts will be together. So the covariance, what is covariance? So variance is always telling about how the data is distributed over the center, right? Now the covariance, now what is covariance then? Covariance describes how one variable is impacting another. So let's say till now whatever we have done, the average, standard deviation, median, mean, everything we are calculating on one variable. Average is on only one variable. Standard deviation is also only one variable. Likewise, we did only one variable analysis. Okay, this is called univariate analysis for your information. So that's what we have done till now. But what covariance does is it does things in a little slightly different manner. What it does is it takes two variables and it tries to find out the relationship between two different variables. So it analyzes the relationship between two variables. So what relationship does it analyze? So let me give you an example. let's say relationship of variables. Actually, relationship of variables can also be analyzed using something called scatter plot. Though to only some extent, it won't give you the exact details. Okay, relationship between two variables. Now, the first type of relationship we can think of in covariance is positive relationship. What is a positive relationship? So, for example, let's say your salary and expense. When I say salary, right now I'm considering only monthly salary. Let's say you have a salary of $2,500. Your expense could be, let's say, $1,500. What if your salary is increased to $3,500? Your expense might have increased to $2,000. What if your salary is increased to $5,000 per month? Maybe you're, this time you're spending too much and spending around $4,000. You see what is happening here? The moment your salary is increased, you're increasing your expenses. Why? Because your capacity to purchase new things has increased. So you are purchasing more things. Okay, is that clear what I'm saying? When salary, which is one variable, and expense is another variable, when salary is increasing, your expenses are also increasing. This kind of relationship is called positive relationship. And this actually you can try to analyze to some extent using scatter plots. And what is a scatter plot? Scatter plot is nothing but let me give you a scatter plot. Are you comfortable with coordinate geometry? Only to some extent. I don't want the very deeper understanding. I just want, are you clear with how to plot points on coordinate system? Otherwise I can teach that to some extent.
For me, it's fine, Sandeep.
Okay, Vidya and Abid.
I don't really remember, to be honest.
Okay, fine. No worries. So I'll just teach you whatever the basics are. So the coordinate system generally has, what is a coordinate system? Basically, coordinate system is nothing but it is a way to graphically represent your data points in a two-dimensional space. So on paper, your paper is always two-dimensional. It has, it has width, it has height. Okay, only two, or length and width. You can say length and width. It has only two dimensions. So on two dimensions, if you have to represent your data points and then find out the relationship between the data points, you need coordinate system. Okay, and it has x-axis and y-axis. It's more like addressing. Say for example, on x-axis, and this is it has two axes. The horizontal one, it is called x-axis, and the other one is y-axis. So how do you represent any point on this plane? It's more like addressing scheme. So for example, if someone asks you where is your house, you just say that relative to that, let's say shopping mall, you have to go right and then left and then straight. How did you say that? You are describing your data point, your address based on some other address, and then that basis is the reference point for us. In coordinate system, our reference point will always be the origin, which is represented by capital O, and it always starts with 0, 0. What it means is this is the reference point. Whenever you want to address any point, if you want to say the address of any point, you always tell based on the reference of the origin. So for example, your x-axis, let's say this is 1, 2, 3, 4. These are the points on the x-axis, and this is the points on the y-axis. For example, if you want to represent a point here, you have to name each point using its coordinates, and the coordinates comes from how much distant you are from each coordinate. For example, let me show you one example. Better example I think is this one. So how to give an address to this point? So what I can do is how much distance it is from the x-axis. This one is how much distance it is from the y-axis. You give as an x coordinate. Here it is how much is the distance? 1, 2, 3. 3 is the distance from the y-axis. You keep 3 as the x coordinate, and the y coordinate is nothing but what is the distance from the x-axis, this one, and it is 1 point. So 3, 1 is this point. That's how you represent each point. Similarly, what is this point? Vijay, can you try?
Will it be 2, 2?
Yeah, I cannot give the exact coordinates because I am not on a graph paper, but you're right. Can you tell this one also?
1, 3.
Yeah, 1, 3. As simple as that. As long as you're able to identify the points on the x-axis, I'm fine for now. Okay, in future if you need any more coordinate geometry, I'll describe at that time. But for now, this is enough for me. But this point is clear, right?
Yes.
Maybe you can try out few more points. What about this point?
4, 0.
Yes, you're right. And what about this?
0, 2.
0, 2. So any point on y-axis, the x coordinate will be 0. Any point on x-axis, the y coordinate will be 0. Okay. Hope this clears your coordinate understanding. The very basic.
Yeah.
I'm not going deep into this because we don't need. So we can represent any relationship between any 2 points using this coordinate system. How do we do that? You assume that salary is on x-axis and expense is on y-axis. You can do the other way also. Maybe salary could be on y-axis also, but I mean that is up to you. So to create a scatter plot, choose one axis for each variable, then plot the points. So for example, let's say this is 1k, 2k, which is 2000, 3000, 4000, and here also let me take 1000, 2000, 3000, and somewhere here 4000. Okay, now let's plot what is happening here. Salary is 2500. When salary is 2500, expense is 1500. So 2500 is around here and 1500 is around here. So this is my first point. And the second point is 3,500 and 2,000. 3,500 and 2,000. Around here. And 5,000. Maybe I should keep 5 as here. 5,000 and 4,000. And I am getting somewhere here. So what is happening? It is increasing. When I draw a line through all these points, when salary is increasing, expense is increasing. That is what this line is showing up. Okay, it is an increasing trend. So if you want to find out any relationship between any two variables, all you have to do is draw a scatter plot. Plot each point, assume that one axis is variable 1, another axis is variable 2. Plot the data points, see the trend. If one variable is increasing and another variable is also increasing in the same time, it means that they both share a positive relationship between each other. Is it clear what I am saying?
Yes.
Okay.
Yeah, yes, Sandeep.
But the question is, how much positive? So, for example, your manager called you today and said that he told you it's good, you're doing good. Now, the second question arises for you. You know, how much good I am doing according to him? Is it very good? Is it very positive, or it's okay? It's okay, kind of positive. Or someone says, I got a good increment this year. Is it the first question is, did you get an increment? The second question is, how much increment? Is it a very good increment, or is it a slightly, it's a moderately good, or is it a very slight increment? You know, the strength, how much strength that increment is having, how much strength that relation between the salary and expenses. This is what we are the second interest is that one. Okay, but your scatter plot, it's going to give you only the positiveness of your relationship. It's not actually going to give you the real value of that relationship. Is it highly positive relationship, or is it a moderately positive relationship? Those things I cannot infer from the scatter plot itself. We need some other tools. Is that clear? I can say any line on the scatter plot that has some increasing trend is a positive relationship, but it doesn't talk so much about your strength of your relationship. Is that clear what I was saying?
Yes.
Yes, Sandeep.
So that is a problem with the scatter plot, but I'll show you that strength part later. But let me go to negative relationship. Can you give anyone some example about two variables which share negative relationship? When one is increasing, other will decrease? Any idea?
Exercise and weight loss.
Yeah, that's a good example. The more number of hours of exercise versus the number of pounds you lost is always a negative relationship. When one is increasing, the moment you keep on doing more exercise, your weight loss, the number of pounds you lost will always be increasing. So any other examples? I'm just trying to motivate you to think more. In case it's not motivating enough, let me know. Any other example you can give? You can try out many examples actually.
I guess the distance we drive in the car and the gasoline that is left in the car.
Yeah, That's also a good example. Again, in automobile, there are many other examples you can give. For example, many times, the amount of time, the number of years that you used a car and the value of the car, the value of the car after those many years will always be reducing, right? Today you bought a car for, let's say, $1 million, and in 5 years the car will get the value of the car will get depreciated. And there are many other examples even in manufacturing. When the moment you keep on manufacturing some item, the efficiency of the machinery will get reduced over the period of time, due to wear and tear or whatever the reason. So the fuel efficiency of any machinery goes down over the period of time, right? So many of these machinery kind of applications will have this negative relationship. Or the other thing is maybe the number of years of service for a company versus your motivation level, if motivation level can be quantified. Initially when you join a new company, you'll be highly motivated, but over the period of time your motivation level will also go down, right? So all these share a single problem where one variable increases, another variable will decrease. Is that clear? Okay. No, maybe number of years of service. And the fuel efficiency or car, resale value. What is happening? The first year, let's say the resale value is 10K. Second year, it got down to 8K. Here this number of years of service is increasing and the resale value is getting down. 6K. Fourth year, it may have gone down to 4K. Fifth year, maybe it is only 3K. So the moment you increase the number of, you keep using this car too much, the resale value is going down. Okay. Now again, if you want to plot a scatter plot here, let's take x-axis as number of years of service. The second one is value, resale value. Now how much it will be? Okay, it is 1K, 2, 3, 4, 5. Let's say somewhere here I have 10. It keeps on decreasing. First year it is only it is 10K. Second year it is around how much it is? 8K, right? It may be somewhere here. Then it is 6K. Third year it is 6K. Fourth year it is 4K. I'm not drawing exactly, I know. And then 3K somewhere here. So if you combine all this using some line, you don't have to pass through exactly on all the points actually. You'll get a downward trend. If you see a line like this in the scatter plot, assume that you are having a negative relationship between those two variables. When one is increasing, other is decreasing. Is it clear? And finally, there is another type of relationship, which is no relationship. And this means that both the variables that you are talking about doesn't share any relationship. I mean, when one is affected, other is not getting affected much. Okay, it's more like your expense and number of crimes. They are both related, right? This doesn't have any impact on number of crimes, or number of crimes is not impacting your expense at all, unless in an indirect way. I don't know. Okay, 2k, let's say this is, and this is 100. 3k is your expense, and there are 50 crimes in, let's say, New York or New Jersey, let's say, and 5k, and your expense is increasing. Actually, here there is a downward trend, and again there is an upward trend, probably 1000. Likewise 1k and let's say 2000. So there is no relationship actually. You don't know which one is increasing when other is decreasing. So if you plot here, again this one is crimes, this one is your expense, 2k and 100, let's say it is here, then 3k and 50, let's say it is here, 5k and 1000, let's say it is here, 1k and 1000, 2000, it is here. Okay, one is, sometimes it is decreasing, sometimes it is increasing, like this, right? The trend you cannot say. Is that clear? Any questions on this?
No, sir, it's fine.
It's more like one variable is not affecting the other at all. So in general, because I am taking only few data points, you did not see this pattern, but there are some specific patterns to look out for. Specific patterns to look out in scatter plot. What are those patterns? So it's like this. Let's say your data, most of the times, you'll see this kind of band kind of relationship. Okay, you can see if you draw a line in between this entire band, you can see that this is a horizontal line. Or there is another case where it could be like this, your scatter plot. I'm just drawing the scatter plot patterns. If you see this kind of pattern also, again, if you draw a line in between, your line is vertical line, which is parallel to y-axis. In this case, it is a horizontal line. In this case, it is a vertical line, exactly parallel to the y-axis or x-axis. In both the cases, you say that there is no relationship. These patterns you will know only when you try out the scatter plot on comparatively larger data. We'll try to do that now. Okay, this is A. The second kind of pattern is if you see this kind of pattern, this kind of band. Okay, what is happening? When you draw a line exactly in between the band, you'll see something like this. What is it? I said that if you see this kind of a line, you say that this is a positive relationship, right? The same line, except that there are too many points here. That's why you're getting this kind of a band or patch. Is that clear? And in this case, you call it as positive relationship. These are the real world patterns that you will see, not the lines that I draw, that I did draw. This kind of simple lines you will not get. You'll get a band. Okay, that is a real world pattern that you will see. And the third one is you could see this kind of band. Okay, if you draw a line in between again, what you are seeing is a line similar to this, right? Which is a negative relationship. That's what I can tell in this last case. Negative relationship. Is this clear till now what I said about the scatter plots?
Yes, sir.
Vijaya, are you clear?
Yes.
Okay. Let's see how this band looks like in real time. Let's see my data sets. Correlation. Yeah. So here I tried to find out the correlation or the scatter plot between age and weight. Do not worry about all these things. These are all the calculations I'll do again today or maybe tomorrow. Today I don't have time maybe. Okay, we already have all these kinds of calculations, but we'll do this. Okay, don't worry about these things. Worry about only the first two columns. Okay, maybe I'll remove all this. Okay, worry about only the first two columns. The first column is saying age and the second column is saying weight. My expectation is here over the period of time, or I mean the moment your age gets increased, your weight will also get increased. This is why I thought of trying, is age anyway related to the weight of the person? The reason is maybe 10 years back I'm only, let's say, 40 kgs, or maybe I don't know how much it is in pounds. Vijay, are you comfortable with kgs and all?
Yes. Yeah.
Okay, because I'm not accustomed to your metric system. I'll try to in future.
Oh, no problem.
Okay, let's say a few years back I'm only 40 kgs and today I'm 60 kgs. So based on that, based on my experience, I thought, okay, is age in any way related to the weight of the person, or is it only in my case? Possible, right? So I wanted to try out that. Now what I can do for getting relationship between two variables, I can do a scatter plot, right? So what we can do is we can select this entire data of two columns, and then in this Excel you can see the charts here and you can see the scatter plot here. Just select both the columns, click on scatter, and you will get a scatter plot. It's as simple as that. Okay, normally you keep the length of this any plot, length should be more than the height. That way, your plots will be visible nicely. So that's why you drag it like this, whatever I did like this. The length should be more, the width should be less. You can increase a little if you want, but don't decrease too much. Okay, now you can see the scatter plot. Can you identify now what is the relationship between the age and weight based on whatever data I have currently? Is it a positive relationship, negative relationship, or no relationship? Sorry?
No relationship.
No relationship. Because these are the bands that I said. Now you can see, right? You don't get an exact line. Everything won't fit in single straight line. Life is not straight lines actually in statistics. Mostly you'll see everything like this. So what you're seeing here is a band kind of thing. And this band is similar to this band. Anything, if I draw a line exactly in between this band, the line will be very close or very, very much parallel to the x-axis. Whenever the line is parallel to x-axis or parallel to y-axis, assume that these two doesn't share any relationship. Is this clear?
Yes, Sandeep.
Vijay, are you clear? In this case, my assumption is wrong. Age is not related to weight. Vijay, are you clear?
Yes.
Okay. So that is about the scatter plots and how to build a scatter plot in Excel. Anyway, in future, everything will do, all of these things will convert all these learnings into Python. That time you'll do these again, not in so much detail, but at least you'll do, and so that it will be a revision for you. So that is about it for today. So any questions till now?
No questions for me.
Okay, Subbu and Abid, are you having any questions, or we can wrap it up?
Sandeep,
Hmm.
why we call it as scatter graph? Generally, this is a normal graph only. Depends upon from x-axis we are considering age and
Okay.
y-axis weight.
There are many other plots. So here we are calling scatter plot because our data looks scattered, right? Our data points look scattered on the XY plane. We're putting all our data points scattering all our data points on the XY plane.
Okay.
There are other plots. For example, it's not a regular plot. That's what I wanted to say. See, scatter plot is always about plotting the point on the XY plane.
Okay.
For example, if you want some other plot, let's say histogram or bar chart, what you're doing, you're not putting your point on the XY plane. What you're doing is you're trying to count the number of points that represent one bar and all those things, right? So not all the graphs represent a scatter plot. We are calling this scatter plot because we are putting our points on the XY plane, and that looks scattered sometimes.
Okay.
That looks scattered on the plane. It's more like if you take a fist of sand and throw it on your floor. Is it is it scattering or not?
Yes.
You take a fist of sand and then throw it on the floor. Just throw it wildly. Then the the sand will be scattered or not?
Yes, Sandeep. I got it.
The sand particles. This plot will look like the same for some parts of the data. In this case, it is tightly packed. Sometimes what happens is the data points will be scattered over the entire XY plane. That's why it is scatter plot. Okay.
Actually, I have a question.
Yeah.
Does it matter like which variable is on the x-axis or y-axis?
It doesn't matter. For example, you saw this plot right now. let me keep it sideways. Let me copy this. Let me change the ordering actually. That's what I wanted to do. Let me take weight first and age next. Age next, okay. Now if I try to do a scatter plot, how is it looking? Wait a minute.
It's still the same, almost.
Wait a minute. I think the data did not get reversed. E2 and F2. This looks correct. Actually, what I meant is the data, instead of you getting this band, you should get this band.
Okay.
Okay. Let me try to do that again. One second. Let me remove this. Insert and click on scatter. I'm not sure this is like this. Yeah, this is more like little bit scattered over this part, right? Y-axis. Are you clear or?
Yeah. So no relationship.
No relationship, but the only thing is the graph got little bit inverted. Instead of you getting this kind of a band, which is parallel to x-axis, your band is now parallel to y-axis.
Now, if there was a positive or negative relationship, would it make a difference if the variables were changed?
It won't make.
Okay.
It will be same way. If there is a positive or negative relationship, even if you interchange your variables, you will get still the same graph. Okay? Because again, if something is increasing, this one is also increasing. Which means even if you interchange the graph, the only difference is the angle in which it is cutting the x-axis. It may be like this if if x is here and y here. The angle might be slightly different if if y is here. What I mean by y is variable y, not the y-axis. If I interchange, maybe the angle will be different, but the relationship is still positive. Is that clear?
Yeah.
But definitely the angle with which it cuts the x-axis will be different. That is for sure. Unless, it is exactly 45 degrees, in which case, even if you interchange, it will not change. Are you clear with your, did you get your answer?
Yes. And another thing is that can you share the link to your OneDrive so we have access to this exercise?
Yes, I'll do that today. Sorry for delaying that. Today I'll do that.
I got one question, Sandeep.
Yes.
Yeah, where can we apply these scatter plots in real-time data? I mean, I just want to know real-time application of these scatter plots.
The real-time application is you get hundreds of variables like this age and weight.
Yes.
You need to know which of them are related.
Okay.
To know that, the minimum thing you can do is scatter plot.
Okay. Let's say, for example, if I have 100 variables, to determine the relationship between any of those variables, I have to draw a scatter plot first, and then I have to determine relationship.
Yes, but how many scatter plots do you have to draw? Just as a mathematical, challenge I'm giving you. If you have 100 variables, how many scatter plots you have to draw? Between every two variables. Assume that you can draw scatter plot between every two variables.
Okay.
If you have 100 variables, and how many possible combinations you have to try?
100 C2.
Yes, exactly. 100 C2 you have to try.
Okay, so here scatter plots should be drawn in between only two variables.
Scatter plot can be drawn only between two variables. More than two variables you cannot do.
Okay.
That's why you have a concept called regression.
Okay. Yeah.
That is the only reason why you have regression, actually.
Yeah.
Okay.
Yeah,
By the
got
way,
it, sir.
regression, I have already mentioned, regression is the next topic after the statistics. We are
Yes.
not done with the statistics. We still have a lot of things to do. In fact, we have not even scratched the surface. But I'm just saying regression is the next topic that we are going to deal with. And that is going to deal with multiple variables at a time, not just two variables like this.
Yes.
So, okay. Is that clear now?
Yeah, it's clear something.
Okay. Any other questions? Anyway, nice questions. Both Vijay, all of you. Subbu. So keep asking questions. The moment you ask questions, you get more concepts clear. And it's not just for you, others will also get benefited. So it's okay to ask questions. If we have too many questions, what we can do is we can have a doubt clearing session on some weekend. Okay, I can only have on weekends those kind of sessions because I don't want to disturb the regular classes for that. But we can always have any session. That's fine.
Okay, Sandeep, sure.
Okay. Any other questions, Vijay or Subbu and Abid?
No, I'm good, Sandeep. Thanks for your explanation.
Yeah. Good then. Yeah. If you have no questions, we'll close up and we'll catch up tomorrow. Then I mean, on Monday. Then Monday IST, which is Sunday for Vijay.
Yes. Thank
Right?
you.
Sure, Sandeep.
Okay. Thank you.
Bye.
Bye, Sandeep.
Bye.